So in another video, I talked about solving with absolute values, but just as important of that, especially in math 2, is graphing absolute values. So let's talk again about what absolute values are and what makes them special. So absolute values basically are the measurement of a distance from 0. So for example, in this graph, I have a line, and if I'm measuring each point's distance from 0, like their y value, or their x value, sorry, I'm going to take this number, which is 1, and I have a point here, and I have a point here, and all of these are positive over here, so I'm good on this side. So in my absolute value graph, I'm actually going to keep this line because it's in the positive hemisphere, and all the numbers are positive already. If we look at the left side of the equation, though, all of those values are actually negative. And so if I'm going to take the absolute value of this, instead of having it x to -1, I'm going to have -1 to +1, and +2, and +3, and so on and so forth. Because what that does, wow, that line is still off. I'm just bad at drawing lines. What this does is it actually makes all the distances positive, going with our definition. So like this distance is the same, this distance is positive, this is a positive distance, and so on and so forth. So we're really just mirroring it across. And so this black line here is the basic shape of an absolute value function. This is what we call the parent graph. So that this black line here is what we have as the parent function of absolute values, which looks like this. So all of the graphs we're going to be doing in this video are going to have this very distinct V shape with kind of an angle, a really sharp angle there. So there's a couple of different elements to this. I'm actually going to go to Desmos over here, and I'm going to put in that same equation you just saw. So I'm going to have I'm going to do f of x equals to a times the absolute value of x minus h, lots of typing, sorry, and then plus k. So I'm going to add sliders for all of these, and we're going to kind of see what happens. So let's go ahead and start with k. So notice that it's not moving left or right, it's just moving up and down. So when k affects the movement of the graph up and down. H moves the graph left and right. It's not moving its vertical position anymore. It's just going left to right. And A affects a lot of things. So let's look at the positive part first. So when A is positive and it gets more and more up there, it actually starts getting narrower on itself. Notice how it starts to close almost. Whereas if we go to the negative, if we go less than 1, but before 0, it gets flatter. And then we get to 0 and it flips over. So once it's negative, it opens downwards. So looking at these different elements, let's start with k again. So k was the movement up and down. So if I have plus k, that's going to give me an up transformation. But if I have minus k, that's going to bring a down transformation. And what's happening here is we're just adding on a number at the very end of our function. So whatever like the absolute value of x was, now it's going to be up or down because we're adding or subtracting a number to it. H was moving it left to right, and H is kind of a weird one. So all of these things, A, H, and K, represent the position of different numbers. So for example, I could have a -1/2 for A, or a 1 for H, or a K is 2. All of those affect the movement of the graph. So like, let's say I wanted to move 5 units left. So I want H to be -5. So I'm going to move this down to -5. Let's say I want it around here. And I'm going to double check. So I'm going to move this back to its original position at 0. And I'm going to move this back to its original position at 1. So this is my graph just shifted down to the right to -5. So we would think that maybe it would just be the absolute value of x minus 5, but notice that's actually on the opposite side. H is going to be flipped. So let me actually go back here and try x plus 5, and that's going to end up in the same spot as my other one. So when I want H to be -5, I'm going to have it kind of the opposite. So x minus h is going to move us to the right, whereas x plus h is going to move us to the left. And the reason that's happening, there's a couple of reasons. One of them is we originally started 0, 0, and now that we're adding in this number, the graph tries to compensate. And so it's like if I want to go to negative, if I have x minus 5, then I need to go to positive 5 to kind of make it back to where it was before. The other reason is the original graph has a minus there. Minus negative 5 gives us positive 5. So we just have to kind of remember to flip h. All right, and then last but not least, we've got the a. And remember that affected kind of its, I'm going to call it its slope. For lack of a better word. When we had a positive a, it opened upwards, so it kind of looked like a V, but when we had a negative a, it almost looked like an A because it opened downwards, like a capital A. The a also represents the slope, and so if I have a 1/2, it's going to go up a lot slower than if I have a equal to like positive 4. So that's going to affect the slope of our lines. All right, so when we're graphing it, we have got 4 steps. The first one is we're going to find A, H, and K, all those based on the positions over here. The second thing I want to do is plot the point HK. This represents what we call the vertex. And so in each of my graphs that look like this, there's this point at the end, and that is called the vertex. Since H affects its horizontal movement and Y affects its vertical movement, that's why this is going to be like X, Y, respectively. Once I get that point plotted, I'm going to graph the slope of the right arm, just this side over here, and then I'll reflect it over, and I've got my graph. And it looks like a lot, but really it's very simple. So let's go ahead and take a look at some examples. So first thing we want to do is find A, H, and K. So remember, A is located beforehand, so this one's going to be negative 1/2. H is located inside, but we have to flip H. So because it's x minus 1 on the inside, h is actually equal to positive 1, and k is just positive 3. We don't have to flip k. All right, so we did that. Now we have to plot the vertex using h and k. And remember, this is x and y respectively, so I'm going to go to positive 1 and then up 3 and draw my point there. And then I'm going to graph my slope of the right arm. So I'm actually going to do this in red so maybe you can see it better. So my slope is negative 1/2, so I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and just as many as I want to kind of make the shape. And then I'll draw a line that goes through them. And I still can't draw it straight, apparently. All right, and then finally we just reflect it over. So we go down 1 over 2, down 1 over 2, down 1 over 2, and draw another line. And that's our graph. That's it. That is how we graph it. So the hardest part is just recognizing the A, H, and K, and especially the H because we have to flip it. But once you find that, the rest of it is pretty straightforward. Sometimes we might have something missing. So I want you to take a look at this and notice that A is multiplied, but H and K are added. Since we're multiplying by A, if it doesn't appear, we just call it 1. Because if A was 0, we would multiply by 0, and then we wouldn't even have a function to start with. But if A is 1, then it doesn't change the value of the rest of it. If H and K don't appear, those are going to be 0. So if they don't appear, A is 1, H is 0, and K is 0. So let's do an example where something is missing. Again, we start out with finding A, H, and K. Here we have a negative number at the front, but there's not like a number. So we're just going to call it negative 1. H is going to be negative 3 because we have to flip it, and there's a 3 on the inside. There is no K, though, so I'm going to have K equal to 0. And I follow the same steps. I'm going to have H equals negative 3 and K equals 0, so I'm going to go 1, 2, 3, and I don't have to go up or down. And then I graph the slope of the right arm, which is negative 1, so down 1 over 1, down 1 over 1, down 1 over 1. And then I reflect it over to the other side. And there's my graph. Easy peasy. So some things to remember, flip H. Please remember to flip H. There was so many times last year where they forgot to flip it, and it really makes a difference in your graph because it's in the totally wrong hemisphere. So please remember to flip H. And the other thing is if A is negative, the graph should open downwards. So you can always double check your work by double checking A and seeing where it's facing. Hopefully that makes sense.